If you watch my last video, you may recognize these pieces as what's left over from the testing of that bridge. It's broken now, but what I'm going to show you in a series of videos is how I built this bridge, and hopefully in enough detail so you could reproduce it if you want to give it a try. Some of these components can be built independently of each other, so you could do them in parallel with multiple people, or you could just do them sequentially yourself. The different pieces that we're going to focus on and how I'll break the video up will be, this first video will be all about building this hanging platform piece. This is the piece that holds the loading block under the bridge, and it can be built completely independently of the rest of the bridge. So that's what we're going to build today. The next video will focus on the sides, so I build the sides separately, and then another video will be doing all the cross bracing, and then the final video will be final assembly, how to attach this piece to this bridge, and doing the final polish parts of it. But for now, we'll set that piece aside and focus on this piece here. So it looks fairly simple, and it is fairly simple, but there are some unique challenges that to build this that aren't really part of what some of the conventional bridges that we've built in the past have. So I wanted to go through in detail how I did this and just talk a little bit about the materials used and what what the process was for that. So if you remember the rules, if the bridge is being tested like this, this platform, the bottom of this platform is on the plane of the testing blocks. So the rules say that the loading block, if we put it on here, can't be more than 1 centimeter above that plane. So what that means in terms of this device, or this piece of it, is this width here can't be more than 10 millimeters tall, or it would be too high. Unless you want to try and hang this below the plane, which would be legal, but that just adds more mass and more difficulty. So I wouldn't recommend that. So what I found was a reasonable choice was this width is 7 millimeters from here to here, which gives us a nice little buffer for following the rules. And what that means is this is also, so these joints are super critical, as you can imagine. It has to hold the entire weight. What that means is I've used fairly dense material here. I would call this, at least medium density balsa, unlike typically the rest of the bridge components, which are more on the light end. These components are basswood, these wires I call them. I've been using 1/16 by 1/32 inch basswood for this, and that seems to work pretty well. And it's aligned, so you have the skinny side all facing the same direction, because when we install this, it will bend in. So you want to be bending the skinny part. But we'll talk about that more as we build this. Okay, so how do we build this? It can all start with, all right, so this is a finished one, or what's left over from that. So we'll put that away. It all starts with just a single piece of wood, which is going to be the base. And of course, I like to keep track of this. So we'll call this up here I called it the bucket base. We can call it, a platform base. And I like to use, or I historically have used 1/16 inch thick by 7 millimeters. And the individual lengths are 6 centimeters. And there'll be 4 of them. So that means this whole piece here has been pre-cut to 24 centimeters. And I also like to weigh these components ahead of time. And right now I'm really just going to duplicate what I did in the previous build, because I know that's good enough to hold the whole thing. And we're at 0.614, so almost the same as the other one. And then just for completeness, here are the 4 wire pieces, I call them. Call it wire. This is 1/16 by 1/32 bass. And these are 15.4 centimeters. And these get trimmed later, so this is a little longer than is necessary. And again, there's 4 of them. They're all equal for the most part. And what do we got? 0.387. So again, very similar to the previous build. So that's what we're going for. Okay, so now what we do, the trick is to, if we go back to this completed one, the general idea is to notch out halfway on every piece of this, and then they stick together, or they slide together, and create this flush seam. So a good way to do that, I will show, is, so here's our, let's see if I can get this fully in view as close as possible. Okay, so here we go. It goes from 10 to 34. So this is 24, exactly 24 centimeters. We want each piece to be 6 centimeters. So we definitely need cutting marks at every 6 centimeters. 6. 22. 28 and 34. All right, so now this is these will be our 4 pieces. But before we cut these, what I like to do is mark the where we're going to notch this out. So it turns out that I've designed it so at 1 centimeter from each end of each piece is where the notch is. So keeping the ruler here and using the Sharpie, I like to just put a dot right in the center. So 1 centimeter to either side of our cut marks. And don't forget the last one. And try and get it as close to the center as possible. Okay. So now we can cut this. Got my nice miter cutter here. And try and be as accurate as possible. Okay, so here are our four pieces that are going to form the base of our platform. Now, how do we notch this? So originally I was thinking you could do it with an X-Acto knife, and you probably could. If it was very sharp and you're very careful, you could just notch that out. But what I found worked really well was my rotary Dremel tool here has a cutting disc that is almost exactly 1/16 of an inch thick, or it works out really well for that. So the trick is to use this rotary sander to sand out as close to possible to the middle of each of these notches. So we'll see if we can pull that off here and keep it in camera. And you obviously want to take your time and be extremely careful with that process. You know, you can practice on scrap wood if you to get that technique down. But now we have these 4 pieces. They're all notched. And hopefully, if this works right, we can just connect up the notches. You know, you slide the notches together with these 4 pieces, and it will be snug, should be snug. Now, you see, I don't want to like just jam this together, or it might break, or do you know, apply uneven pressure. But you do want to get it completely pressed together as close to possible, as close as possible. So what I like to use is another loading block to just push on here to try and get this fully squeezed together. And you know, if it breaks, or if it doesn't work completely, it's really okay, because this is just the you know, you don't lose very much work if this part doesn't work right. You can just start over. But using this to press this down gives you a nice firm fit. So that's pretty good. Let's see if we can see that. So now that's pressed together, but you'll notice it's still, you know, it's still skewed. It's not perfectly square. So before we attach our wires to this, we want to try and do that process. And before we glue it, we want to have it be square. So that's where the first jig comes into play. And this is actually a very simple jig. It's really just a long, you know, extruded rectangle that's the right size. And I've taped on some scrap balsa up here to help align the wires. And I'll show you that in a minute. But what we want to do is get this piece on this jig. All right, so that's pretty good. And it doesn't need to be, you know, at the bottom. It just needs to be anywhere along here, but make it as square as possible. So that's pretty good. And what I've found, because it's not super tight, you can use just some blue tape to kind of tape this in place temporarily, to hold it in place. So this is blue painter's tape. It's not, it's made to be temporary and come off relatively easily without damaging what it's taping. Okay, so that's pretty that's reasonable. Okay. Okay, so now the next step is we are going to glue our wires on here. And you want to if you've created this, you can create your own jig if you want to 3D print this part as part of this, but I found it was just easier to tape this piece on. So here's one of our wires. You want to have the flat part. Here's the general idea. We're going to glue that on like that, right? And we use the jig as kind of a guide to keep this aligned and to help glue it as square as possible. And let's see if I can show this. We're also going to want to try and glue this flat onto this piece, but also have it be touching this edge piece. Because of course this joint is extremely critical. And we're also going to reinforce this joint when it's done, and we'll do that in a minute. But I think we're ready to glue that on place. So get a little glue. It's somewhat tricky to get this going. Okay, so I like to put the glue on the thing you're gluing to. So put the glue right there. And this is just the first one, so we'll hold it in place with the pin. You kind of just make sure this is aligned as straight as you can get it. And then we'll hold that there for a little bit. Okay. Now we're basically going to just do that again for the other sides. And again, this piece on the top is really just to help you glue it flat and to see the proper alignment. Okay. And actually, while we're here, we're going to be gluing every single one of these seams. So we can glue these two right now. Just put a little dab of glue in there. Now we're going to just repeat the exact same thing on the other side. Make sure you keep the flat side in the direction you need it to be. Using the pin to hold it in place is very handy because it's small enough and you're not trying to jam your finger in there and have it get stuck. Okay, I'll glue this joint and that joint. So now all the joints around it are glued. So now we can take it off this jig. So we can take our tape off. And with any luck, it should slide right off. There we go. And now we really want it to just reinforce the rest of these joints. So now we can glue the inside joints. Yep, that's pretty good. Now, what I like to do with the supercritical joints is to add some more glue and then immediately put some accelerator on there to completely cure it. That makes it strong immediately, and it allows you to, continue this work. If you were just going to build this bridge and attach it later today, you'd want that to be strong. So now I like to put a generous amount of glue here, maybe 2 dabs, and just drop one tiny drop of accelerator there. We'll do that for all 4 sides. Okay, and that is essentially our finished platform, and it's going to be like this, and then these pieces will come together and attach to the bridge. Let's see how much it weighed. Let's see. Completed weight was 1.1 grams. So that's not bad. So, and I'm confident that this can hold the whole weight. Now for optimization, you could definitely look into making this a little less dense. You could look into making it thinner. You could probably maybe go to 1/32 by 1/32 higher density bass, which might save a little weight. And it might also be possible to build a standalone test jig just for this piece. So without having to build the rest of the bridge, you could build versions of this and attach this to something that simulates the top of the bridge, but maybe is just a piece of wood, and then hang the bucket from there, and see if your design optimization works, or at least gives you a good idea that it would work. That way you don't have to build the rest of the bridge to iterate on possible design iterations or material optimizations for just this piece. So there we go. So here's our bucket, and in the next video I will look at building the sides of the bridge. I'll put the STL in the description for this jig here. You'll just have to use your own scrap wood and attach that. But it will be the correct size to deal with the platform as designed here. Thanks for watching, and stay tuned for the next video.